Welcome to this practical session. My name is Massimiliano. I will introduce you to the exercise with the physical fields data produced by the Mediterranean CMFC of the Copernicus Marine Service. Now let's go through the notebook. The objective is to visualize maps and vertical sections of the main physical fields. We will also compare how the fields are in two different seasons, summer and winter. The data is produced by the physical component of the MED-MFC, which is a couplet hydrodynamic wave model corrected by a variational data assimilation scheme of temperature and salinity vertical profiles and a long-track satellite sea-level anomaly observations. In this model, we have horizontal grid resolution 1/24th of a degree and 141 unevenly spaced vertical levels. The available temporal resolutions are hourly mean, daily mean, and monthly mean. In this exercise, we will use monthly mean fields. This box shows the parameters to download the data we need. We use the monthly mean field datasets of temperature, salinity, mixed layer depth in month of January and September 2019. In the first part, we plot maps. For your convenience, here you will find all the useful information to set up a local working environment suitable for this exercise. However, in this notebook, I remind you everything has been already prepared. Now we import the needed modules. And we read the local copy of the data. Starting from the temperature dataset, we can inspect the associated information. The coordinates, the data variables, and the attributes. The same for salinity. And the same for mixed layer depth, in which we can notice the depth coordinate is missing because it is a two-dimensional field. And finally, we go to visualize the first map. This map shows the surface temperature in September. After the first plot, we provide some suggestions in this box. But now let's go to the second part, and later we come back here. In the second part, we plot transects of temperature, salinity, and water density in the North Adriatic Sea. First, we set up all the parameters and the functions we need. And here is the plot related to the temperature in January. And the plot related to the temperature in September. It is possible to notice that in winter, here, we get our mixed water column, while in summer, here, we get a stratified water column. And now the salinity. In January, here, and in September, here. And also in this case, you can notice the differences between the 2 months. In winter, we get a well-mixed water column, while in summer, we get a stratified water column. Now we can compute and plot the water density and show in the same plot the mixed layer depth. In January, the transect of water density and the black line mixed layer depth. And in September, the same plot. Again, you can notice the differences between the 2 months. In winter, here, we get a well-mixed water column, while in summer, we get a stratified water column and a shallow mixed layer depth. Now it's time to go back to the first part. We can change the code and visualize the map of mixed layer depth in September. And here it is, the mixed layer depth in September. The mixed layer depth is an interesting field. It represents the thickness of the layer in which the water is well mixed, so that all the properties of the water are homogeneous. And now let's do this in January, changing also the color bar. (200 meters) as max value of the color bar. And here is the mixed layer depth in January, in which you can notice the field is deeper. Very good, now you are ready to change other parameters and play with the source code. Changing the depth level of maps, this parameter, changing the min and max values of the color bar, this parameter, changing the area, this part in place of the default here, changing the variable. Here you can choose among temperature, salinity and mixed layer depth, changing the position of the transect, here, and go further and try to visualize other variables and diagnostics. And this is it for this demo. Hope you enjoyed it.